So how do we go about saving and loading our video games in Unity? There are a few ways, such as player prefs, which allow you to save and load information related to the player preferences, such as the screen brightness or game volume. While this method is quick and effective, it's only suitable for individual values. If you had something more complex, such as the player game data and progress, you need something that's a little bit more extensive as well as secure. Another form of saving and loading game data is used through XML and JSON, which stands for JavaScript Object Notation. These methods of saving and loading game data are excellent for modding capabilities because they are easy to read and allow gamers to tweak game data. The issues with these methods, however, are that players can easily manipulate them. So what solution are we left with? This is where binary data comes into play. Binary data is difficult to mess with and allows you to securely save and load player data without tampering. There are a few limitations to working with binary data in Unity, and it comes down to what information can be serialized, also known as written to a file. Not to worry though, as I'm going to show you a quick way around those limitations, right now. Hey, what's up? John here with Game Dev HQ, bringing you amazing content weekly related to all things indie game development focusing on Unity. We have an incredible team putting together videos focusing on everything from game development news and development strategies to coding in Unity with C# and getting familiar with the graphical pipeline of Unity, working with the post-processing stack, level design, and more. So if you're new to the channel, welcome and consider subscribing. Here we are in Unity. We have this awesome UI panel created by one of our members, Danny Marty, creator of Crumbling World, a procedural RPG being developed for mobile in Unity. A link to his game trailer is in the description. In our game here, I can hit the space key and simulate the effects of randomizing our stats. Now on our actual player, if we were to select our knight, we have a player script, but inside that it's just randomizing the stats. It's pure simulation. So what we need to do is actually create stats for our player. So to do that, we'll create a new C# script and let's call it stats. This class is going to act as a blueprint for what defines our stats. We're not going to need to attach this to any game object, it's just going to be a blueprint form. So here we're going to remove monobehavior and we're going to define what our stats are. So we'll have public int life, we have vitality, so public int vitality, and then we also have attack and defense, which are also going to be integer values. So here public int attack and public int defense. Now if we save this, how do we go about making use of it? If we go back into Unity, I can't attach this object to my player. The reason for that is because it doesn't inherit monobehavior. It's just a bare bones class template or blueprint for what defines our stats. In order to make use of it, we need to hop into our player class, which is a monobehavior, and we need to treat it like a variable. Basically, we're going to create a variable of type stats and give our player some stats. So let's call it my stats. By doing this, our player now has those stat traits. If we save this and hop into Unity, once it compiles, you might expect to see it in the inspector. However, because it's a custom class, Unity can't read it. In order to read custom classes in Unity, we need to basically add what's called a serializable attribute above the class. If we hop into our stats class, by adding system.serializable, this is going to allow Unity to read this data. So if I save this and hop back into Unity, because it's a public variable in our player class, once it finishes compiling, we can now actually see our stat variable. So here's my stats, and within that we have values like life, vitality, attack, and defense. The next part of this is going to be mapping our player stats to what's on the UI. Now, because this isn't an actual game and we're creating simulation here, I have a method that's just going to quickly map this data for us. You'll see here that as the data changes in the UI, it's not changing in my player down here. And the reason for that is because inside of our UI manager class, we have a method here called map values to player. Every time we randomize our stats, we basically want to update the player to have the same stats. It's just for simulation purposes. Within here, all we're doing is finding a reference to the player and grabbing its stats using the myStats variable that's on the player and assigning it what's on the UI. Really simple, and it's purely just for simulation. So if we save this, let it compile, you'll now see that whatever our UI is matches our player. So right now our defense is 68 and our defense stat on the player is also 68. So now that we have the data, we can actually begin to look at saving and loading. To get started saving and loading, we're going to create a new C# script, and let's call this our save manager. Now, our save manager can stay inheriting from mono behavior. It's just going to live in the scene, and we're going to have two methods in here. We're going to have a method for saving, and then we're also going to have a method for loading. So here, public void save and public void load. Now, before we go any further, let's talk about the process that needs to happen here. When we save our data, we need to first declare a file for our data to be saved to. And if that file doesn't exist, we need to create that file. So when we save, we need to create a file or open a file to overwrite it, right? So create a file or open a file to save to. The next part is we need to use what's called a binary formatter. And this is what's actually going to allow us to convert our class object to binary. So binary formatter allows us to write data to a file. And there's a specific function that allows us to do that, and it's called serialize. So the binary formatter has a serialization method to write to the file, and that's all we have to do. So in order to do this, we need to create what's called a file stream. And a file stream allows us to basically specify a location on our operating system where we'd like to store this file. In Unity, we have a dedicated place to store game data called persistent data path. So in order to get started, we need to include a namespace called using system.io. So this is the input-output class or library. And what we need to do here is now we can create a file stream. So create a file or open a file to save to. So we're going to create a new file stream variable, and let's call this file equals a new file stream. And when we open a parenthesis, we can read the tooltip. It's looking for a path. That path is going to be the Unity dedicated location for saving data. And that's in the application.persistentDataPath. Once we're in that path, we can actually organize our data within folders. So I'm going to hit plus to append a folder location. I'm going to go into that folder location of persistent data path, and then I'm just going to call this player.dat. Now, the industry standard for creating binary data is to just use a .dat format, which just stands for data, or a DAT file. Now, alternatively, though, you could name this whatever you want. So if I wanted to, I could say player.whatever, but in terms of industry best practices, you should always use player.dat. Now, once we have that, we can open a new comma here, and it's looking for a file mode. That file mode is what do we want to do with the file? Are we creating a file? Are we opening a file? Or do we want to do both? There's something called file mode dot open or create. That's going to open an existing file, and we can overwrite it. Or if it doesn't exist at this path, we're going to create this file. So that's the file mode that we want to use. Once we're done, we can add a semicolon. So we've created a file to store this information. The next part is creating a binary formatter. Now, in order to use the binary formatter, it's part of the using system namespace that is going to be a little bit longer than system.io. A really quick way to get this is if we type binary formatter. Our tooltip here should give us some quick actions, and we can actually see using system.runtime.serialization.formatters.binary. By clicking it, it's going to automatically add it here, and we can now create a binary formatter. So to declare a new binary formatter, we just create a formatter. So binary formatter, and we'll call it formatter, equals a new binary formatter. And that's all we had to do to create it. The next part is to actually serialize our code. So to do this, we're basically going to take the formatter, and we're going to call the serialization method. And when we do that, it's looking for a stream, which is basically the file to save to, and then it's looking for object data. What type of data do you want to save to this file? So for the file stream, or for the stream, we're going to use our file, and then for the data, it's going to be our player stat data. So right now in this script here, we don't have access to our player. So what we need to do here is we're going to create a reference to it. We're going to say private player, and we'll say player. And then using void awake, we will find player and assign it. So here we're going to say player equals game object. We're going to search through all of the game objects and we're going to find an object of type player. Once we have that player, we're then going to pass it in through here. We're going to say player.myStats. And that right there is going to be the process of saving this data. There's one very important last step that we forgot, and we want to make sure that when we open or create this file, once we save it, we need to close that file. Otherwise, it's going to stay open for the life of the program, cause errors, and create memory leaks. So to close it, we simply just type file.close. Now, this implementation here is very simple to understand. When it comes to best practices and industry standards, though, this is poor practice. You actually don't want to write your serialization methods like this. For starters, if you forgot to add your file.close method, you're already implementing bad practices and errors in your program. Also, what if we're trying to serialize data that can't be serialized? How would I know? For example, Unity doesn't let us serialize Unity methods or Unity custom creations such as vector3s, quaternions, and color. So what are the options to not only catch those serializations, but get around those workflows? Let's take a look at some of those limitations. So in my stats here, if I wanted to store the position of the player, I can't say vector3 or vector2. I can't say public vector3 my position. All right, because that's a Unity specific thing, it can't be serialized. Same goes for quaternion as well as color. So what are my options? Now, you may think, hey, I could create a float array and assign the X, Y, and Z, or for colors, RGBA values. However, imagine you were saving 20 or 30 different colors of these. You're going to have over 100 float arrays in your program. Doesn't make much sense, right? So instead, what we're going to do is we're going to do what industry best practice says, and that's to create a serializable vector3, a serializable quaternion, and a serializable color. Let's take a look at how we can do that using what's called a struct. A struct is very similar to a class in the fact that it's basically value types, and it's stored a little bit differently in memory. To declare a struct, we basically say public struct, and let's call this serializable vector3. Within this struct, we're going to have a float x for the x value, a float y for the y value, and a float z for the z value. By doing this, we can then hop into our stats here, and I can basically now create a public serializable vector3, and let's call it my pose. Inside of our game programs, I could literally just come down here, and I can say vector3, let's call it pose equals transform.position, which equals our current position. So we're storing it in a temp variable. And then I can simply type pose.x equals our serialized vector3x. So to do that, I'm going to say my stats dot my pose, and then I want to get the x value. Now, if we look in our stats here, they're private. We need to make these public. So here we're going to say public float x, public float y, and public float z. And if I go back to the player here, I can say my pose.x, and we'll do the same thing, pose.y equals my stats.mypose.y, and then here we say pose.z equals my stats.mypose.z. And then once we assigned all of the values from our serialized vector, I can simply take my current position and assign it to the pose, or the new position. And that works just fine. Alternatively, I could actually create a helper method within that class. So if we look inside our stats here, I could create a new method in here that's going to return a vector3. So here I could say public vector3, and let's call it getPose. And we're just going to return a vector3 with the x, y, and z values of our struct. So here we're going to say return a new vector3, and we're going to define it by x, y, and z of our serialized data. So by doing that, I can hop into the player here, and instead of doing all of this using a temp variable, I can literally just say that transform.position equals my stats.mypose.getPose. And that is going to allow me to use those values and still serialize this method. So using structs is a very good way to get around the limitations of not being able to serialize things like vector3 or color or quaternions. All right, instead of using a float array, use a struct. So for this, let's go ahead here and continue saving this data. So we know that we can save this data. And if I wanted to here, we can already save it. If we run this program here inside of my player class or inside the save manager, I've added here to save the data in void awake. What we need to do now is save the data that's on the UI. So it's already mapped to the player. We need to now call this save method from our UI. So here, when we go to our night or on our UI manager here, let's go ahead here and select this next button. And on this button next level, we're basically going to add a new object here. So our save manager basically needs a place to live. So inside of our hierarchy here, let's create our save manager. And let's attach the save manager script. And on the canvas UI, let's go back to that button. And we're going to add a new onClick event. And basically the method we want to call is save. So here on the save manager, we're going to drag that object here. We can then hop into the save manager and we can call the save method. Let's save our scene. And let's run the application. So here, you'll see here that I'm not going to click the next button yet. If we look at our player here, we should see here that on our night, our stats are 0. If I randomize them and simulate it, we now have 48, 99, 80, and 57, and that does match all of our stats here. So life is 48, 99, 80, and so forth. You'll also notice that we don't actually see our serialized vector in the inspector here. And the reason for that is because if we look here, the public struct serializable is not serializable. So we need to add above it, just like our class, system.serializable. By doing that, we can then actually see this struct inside of our MyStats in the inspector. So let it compile, and you'll see here that we now have a MyPose data field. So here MyPose, and we have our X and Y values. So I'm going to set that to 5, 5, and 5 to start. And then let's go ahead here. Let's run our application. Let's get some simulated versions of our stats. So here we go. I'm happy with these. 108, 76, 73, 114. I'm going to hit the next button. And I want to make sure that we're actually I believe we are clicking on that, but I have no actual feedback here. So one of the things we want to do is inside of our save manager, let's go ahead here and add a debug.log saving. So here we go. Let's go ahead and get some simulated values. Right now, our position is 555. Let's set it to 25, 25, and 8. And I'm happy with these values. So I'm going to go ahead now and hit the next button. And you'll see here that says saving. Perfect. So what we need to do now, and there were no errors, which is great. And we'll talk about how to clean this up to a best practice industry standard at the end. The next part here is going to be loading this data. So let's hop into our save manager. And within this script, what we need to do now is basically do the reverse. So for loading data, essentially what we need to do is, once again, we need to open up a file stream for the file location. We need to create a formatter to deserialize the information, and then we need to deserialize and then close the file. So again, we're going to create a new file stream here for the file that we want to read for loading our data. So we'll say file stream, and let's call it file, equals a new file stream. The file that we're looking for, what's the path of the file? Well, it's the application.persistent-data path, and we're going to append where our file location is. So here it's /player.dat. This needs to match exactly where you saved it before. For the file mode, we're just going to do open because we're going to read that data. So we're going to open this file. Once we have that, we need to create our new binary formatter. And let's just call it formatter equals a new binary formatter. And that's going to allow us to read the file in binary and convert it back to an object. The next part here is to do the process of deserialization. So to do that, we're going to access our formatter, and we're going to use the function called deserialize. When we deserialize, you'll see here that there is one of two options here. We can catch an exception handler, which is awesome, or we can do a file stream. So basically what it's looking for here is, what object do you want to deserialize, or what file? So here we're going to pass in our file, and that's going to return deserialized information. Now with this though, you'll see here that if I reopen the parentheses on this again, how do I know that I need to assign this to something? Well, it says right here that it's going to return an object. And based on what we pass it into the stream, which is our file, that's the object it's going to return. So what we need to do is we need to assign it to something. So what do we want to assign here? Well, it's our stats. So here I'm actually going to say player.myStats. We're going to say underscore player.myStats equals the file that we're reading. Now it's still giving us an error here because it's an object. We need to cast it as a stats class or a stats object. So to do that, we can just cast it using parentheses as stats. So here we can type stats. We can cast it like this. Alternatively, you could have said as a stat. So both of these methods work. There's no difference in which one you choose. They do the same thing. All right, so we cast it. And then the last thing we need to do here is we need to make sure that we close the file. All right, and once again, this implementation is poor practice. At the end, I'm going to show you how we can really optimize it and clean it up. Because once again, there's no way to know if there's an error deserializing this field here. So we'll get to that in just a moment. All right, so let's give this a try. Let's go ahead here. Let's call load on void awake. So when I call the load method, it should automatically set it back to whatever our custom data is. And the only thing I really remember here is that our position values were about 25, 25, and 8. So let it compile. Let's load it up. Now you'll see here that the UI didn't update, which we can fix. But if we look on the night, you'll see here that here's all of those loaded values, 25, 25, and 8. If I change these again, let's go ahead and do 13, 5 for the position, and 1 on the Z. And then let's go ahead and randomize some numbers here. So 8379, let's hit the next button, saving. Let's reload this, and you'll see here that the data is going to come back as our new data. And there you go, 5, 13, and 1. We have successfully created a binary save system with loading. Now, if I wanted to update the UI display, I would just do the reverse of mapping it. So I would just basically take the UI values, pass in the player, and grab that data. So let's take a look now at optimizing this. This is poor practice. The reason that it's poor practice is it's too prone to errors. For starters, I can't even check if what I'm serializing is capable of being serialized. We talk about the limitations of serializing Unity data, but how do I handle if I try to serialize something incorrect? Or what if I forget to close this file? What are the problems with that? And that creates severe errors in your applications. It can create memory leaks, and it could just be a complete headache in a larger project. So one of the things that we can do here is we can actually put this into what's called a try-catch block. And what it's going to do is it's going to try and read the file. If there's any errors, then it's going to catch those serialization errors, and it can throw an exception, and you can handle it however you want. And then we can add what's called a finally block, and that will make sure that we always close this file stream. So to clean this up using a try-catch block, what we can do here is we can basically add the try keyword. And what is it that we're going to try? Well, we're going to try and format the data or serialize it. So here we can have our file stream here. This is going to go on top. So we're going to create our file. We want to have the file stream open. And what are we going to try and do now? Well, we're going to try and do the binary format and serialization portion. So we're going to try this. If there's no errors, then we have nothing to worry about. But if we do have errors, it's going to automatically catch those errors inside of this block. Automatically, the C# program will catch those errors. And what we can do here is we can tell it what type of errors to catch. So I want to catch what's called a serialization exception. If I type in serialization, there is nothing for exception. So what we can do here is we need to include the namespace system.runtime.serialization, and that should allow us to use those exceptions. If I come down here now and type serialize exception, you'll see here that it's available. Serialize exception, and then I can store the exception in a variable called, let's say, E. And then what we can do here is we can basically say debug.log error, and we're going to say there was an issue serializing this data. And what we can even do here is we can print it out what the issue actually was. It's going to be stored in E. So the E.message, and that's going to tell us exactly what went wrong. Now, there's one last part of this. We need to make sure we close this file. So finally, we add what's called a finally block, and we want to just say file.close. So no matter what happens here, we are going to close this file. Now, this implementation here is an industry best practice for serializing methods. It shows that you take into consideration problems that could be foreseen, such as exception handling with serialization, like you're trying to serialize something that shouldn't be serialized, or there was an error in the process, or your file data persistent path just is null. Anything like that will be caught in this catch block. So last but not least here, let's clean this up. I'm just going to remove some of these comments here. We don't need that saving log. So we open the file stream, we try to serialize the data. If there's an error, we catch it, and finally we close the stream. Let's clean up this, and then we can do the same thing for our load method. So for loading, we're going to do the exact same thing. We open up our file, we're going to try to serialize the data or deserialize the data. So we're going to open up a try catch block, and we're going to try the binary format. And if there's an error, we're going to catch it. So here we're going to catch any errors, and we're going to use the serialization exception, and we'll store that in E. And if there is an error, once again, we're just going to debug.log an error, error deserializing data, and we're going to add E.message, which is going to tell us exactly what's wrong. And finally, we need to close our file. So file.close. And then we can clean up this file, and we're good to go. Thanks to all of our awesome GDHQ Plus and Pro subscribers who make this weekly content available, and special thanks to Lucky Ducky 10 and OJ Zach. You guys are amazing.